A very good evening to all present here. I am Runali Chitalya and I'm the speaker for today's session, that is Wi-Fi controlled car using Bolt IoT and Arduino. Speaking about myself, I am a final year student of Electronics Engineering of the Maharaja Sayajirao University of Vadodara, Gujarat. And I have been passionate about all these microcontrollers and robotics and stuff from when I was in a school. And since then, I have made various robots, such as a line follower bot, a voice and gesture control bot, and of course, this Wi Fi control bot using Arduino and several other microcontrollers. And continuing the passion, I'm now working on an autonomous quadcopter for my final year project, which is based on ARM Cortex microcontroller. And after all this, I must say that on this journey, I have made a lot of mistakes. And of course, I've learned a lot. And I'm very excited to be here to share my experience with all of you. So let's start with the presentation now. These are the contents that we'll be covering today. First, we'll go through the aim and then go through the components that we have used. Then we shall see the circuit diagram and understand the proper working of each and every component. And we'll later go through the hardware and software, and I shall try to explain you the code. At the end, we'll see modifications that you can make on this board to make a new variant of yourself. Starting with the aim is to make a Wi-Fi operated car that works using the Bolt module and an Arduino Uno. It works on a few buttons like forward, reverse, right, and left that have been created using HTML and JavaScript on the Bolt cloud. So before starting, I would like all of you to see this video. I'm sure you might have seen this on the registration page as well, but this is what we'll be learning throughout this session. Uh, this on the phone that you can see is the app or the web page that we're designed to make. It has several buttons like forward, backward, left, and right. And as you press the button, the bot is moving as per the button pressed. Now moving to the components, these are the components that I've used. The Bolt Wi-Fi module, of course, then Arduino Uno, or if you get your hands on a BOLTDUINO, you can use that as well. For the motor driver, I have used L298N DC motor driver module, then battery operated motors and its wheels, caster wheel, batteries, jumper wires, and for the chassis, you can use any a metal chassis, wooden, ply, or acrylic sheet, whatever you get your hands on. Starting with the Bolt Wi-Fi module, I'll briefly describe what the module has. So the module basically operates on 3.3 volts, but the supply voltage that it uses is 5 volts because it's readily available in the market. If you have a 3.3 volt source, you can connect it directly to this pin. This is the ground pin. There are 5 GPIO pins, 0, 1, 2, 3, and 4, and all of them have PWM output on them. There is one analog pin, and the RX and TX pins are used for UART communication. Now, for my motor driver to work, I needed 6 digital GPIO pins, the reason for which you will see in the following slides. And that's the reason I had to use an Arduino with it. As you can see, this is an Arduino. It has 14 GPIO pins from here 0 to 13, and there are 6 PWM output pins on this. Also, Arduino also works on 5-volt input voltage, and it can take up to 7 to 12 volts from battery. So you can directly connect a 9-volt battery from this barrel jack that is readily available in the market. There are 6 analog input pins, and Arduino also has UART communication, which is also there in the board. So you can connect the bolt and Arduino using those RX and TX pins that you can see here and connect it to these 2 pins RX and TX on the Arduino. Or you can get your hands on a BOLTDUINO. BOLTDUINO is a version of Arduino that is developed by the Bolt, and as you can see, there are similar kind of pins on this as well. 14 GPIO pins, 6 analog input pins. There is also UART communication on this, but the benefit is that the Wi-Fi chip is on board with the Arduino. So instead of using two boards, you can just use one of these. It will be better because your hardware will be reduced. Next are these motors that I have used. These are the battery operated motors. I have used 150 RPM motors. You can use any depending on the speed that you desire. For a bot like ours, which needs to be running on moderate speed, these motors are sufficiently fine. And these are the wheels that are compatible with this motor. Next is this L298 motor driver. There are 6 pins on this motor driver. As you can see, there are two enable pins, that is enable A and enable B, and there are four input pins IN 1, 2, 3, and 4. These 6 pins get input from the Arduino, that is to change the direction of the motors or to set the speed of the motors, at which speed they will be running. You get signals from Arduino, and those wires are connected to these 6 pins over here. It has a 12-volt jack, which can handle voltage up to 5 to 35 volts actually. So you can connect your batteries in this port. There is a ground pin and there is a 5-volt pin. This 5-volt pin is used as an output voltage port. So if you don't want to connect an external battery to your Arduino or to a BOLTDUINO and you directly want to power it from this motor driver module, you can do it by connecting a wire from this module to the BOLTDUINO's input port. Then there are two ports. There one is out 1, out 2, and second one is out 3 and out 4. Here you connect your motors. So your motors get the power from these two ports. One side of the motors you can connect on this output terminal, and the other pair of the motors you can connect on this output terminal. So there are two output terminals for this one. This is the truth table of the motor driver. Now, if you want to connect, if you want to like control your motors, you can do it seeing this truth table. There are two, as I said, there are four input pins. One is IN1, IN2, IN3, and IN4, and two pins enable A and enable B. These two pins, enable pins, are used to control the PWM output or the speed of the motors. So by sending different pulse widths on these pins, you can control the speed of your motors. You can reduce the speed or you can increase the speed. If you don't give any signal, it's by default 1. That means the motors work on the highest speed. And the IN1, IN2. For example, if we take an example of motor A that is connected on this out 1 and out 2 pins, it will be controlled by 3 pins, that is enable A, IN1, and IN2. The enable A controls the speed of the motors, and IN1 and IN2 control the direction of the motors. When you make IN1 and IN2 both high or both low, they are on the same polarity. So the motors won't be running. To make your motors run in any one direction, both the terminals of the motor must have different polarities. So if IN1 is 0 and IN2 is 1, motor will run backwards. And if IN1 is 1 and IN2 is 0, motor will run forward. But that also depends on the connections that you have made over here in the out 1 and out 2 ports. If it's running in the opposite way as shown in the truth table, you can just flip the polarities of your motors on this out 1 and out 2 ports. Then it will run exactly as shown in this truth table. Similarly, if we talk about motor B, it is operated using these 3 pins, IN3, IN4, and enable B. So that's how, using 6 pins, you can control your motors. And that's why when I said before that I needed 6 pins to control my motor driver, this was the reason for it. Also, if you want both your motors, motor A and motor B, to run at the same speed, using the same port in the Arduino, you can connect these 2 pins on the motor driver. So that way, your work will be done with 5 output pins. But in case if you want to modify the speed of the motors, because if you want to make it turn or something, then you'll have to run both the motors at different speeds. So that's when you need 6 GPIO pins in total. Next, this is the PWM chart. That is, what is pulse width modulation? A pulse width modulation means that your entire pulse is divided into different segments. Say, for example, if you want to run a fan, if your fan is running, right? So, if you want it to run at the full speed, you give maximum voltage to your fan. If you want to make it run on a lesser speed, what you do is you reduce the voltage of your fan. But the thing is that that voltage regulator that we have on our switchboards, they are either resistive or capacitive regulators because that is an AC source. But here we are connecting batteries to this, to our motors, right? So to control the amount of voltage, instead of using resistors, because then our batteries would dissipate more, the batteries would run out faster. Instead of doing that, we control how much voltage our motors are getting. So if we give 80% pulse width, then what happens is of the total voltage that is of 100%, only 80% of voltage goes to the motors. That's how you reduce the speed of the motors to 80%. Similarly, if you're giving 50% of the pulse width, only 50% of the voltage that you have connected to the motors, that will be provided to the motors. Hence, they'll run at half the speed than 100%. So these are different duty cycles. You can see the graphs and understand it as well. Then these are a few other components that we'll need in the project. These two are the car chases. This one is a metal chases and this is an acrylic chases. You can find any of them on online. I have used a simple acrylic sheet and I drilled holes in it according to my requirements. So you can do that as well. Or you can find a wooden ply nearby and make a car with that as well. These are the batteries. These are very readily available batteries, but these are non-rechargeable. So I have used a few of them in my car. This is a caster wheel. Now in my car, as you might have seen in the video, I have used only two motors that are on the back side of the car, and I have used one caster wheel for in the front because with two motors, my car was running sufficiently fine. And if you want to make a high-speed car, you can use a four-motor car as well, like these shown in the figures over here. So in that case, you won't need a caster wheel. You'll need four motors instead. And two motors of one side, you can connect it to one output port of the motor driver shield. And the two motors of the other side, you can connect it to the other output port of the driver. Next, we'll go through the circuit diagram. Now I made the circuit diagram in Proteus, so I couldn't find a model that was of bolt module. So I have made a rectangular block here and showed only the connections that were needed. But you can keep your bolt module in your hand and verify it together. The 5-volt pin for Bolt, what I have done is I used a separate battery that powered my Arduino, and via the Arduino's output port, this 5-volt pin is an output voltage port. So via that port, I powered my Bolt. So instead of using a separate battery for Bolt, I powered it using the Arduino. Now, the ground between the bolt, the Arduino, and the motor driver has to be common because in digital communications, all the communication happens in terms of ones and zeros. So there is a separate voltage pulse for one and a separate pulse for zero. And there has to be a common reference between all of them. So it's very, very important to connect the ground between all the modules that you're using together, and that ground is connected to the negative terminal of the batteries. No matter how many batteries you use, all the negative terminals must be connected together, and all the grounds must be connected together. Also, if you're using any other sensor, if you're adding any other sensor to this, you have to connect those grounds as well with these grounds. Then I have given a separate battery to my Arduino. So here is battery 2, just the negative is connected to the ground and the positive of which is connected to the VCC in the Arduino. You can also use a barrel jack and power it via this jack. The Bolt Wi-Fi module and Arduino communicate using UART communication. UART communication means Universal Asynchronous Receiver Transmitter. So it's a hardware communication protocol that uses asynchronous serial communication with configurable speed. Serial communication means that it communicates with a reference clock, and asynchronous means there is no reference clock. And um, so there are the RX pin of the Bolt Wi-Fi module goes to the TX pin of the Arduino, because what the Bolt Wi-Fi module will receive is only the data that Arduino will transmit. So TX and RX are always connected interchangeably. What the Bolt Wi-Fi module transmits has to be received in the Arduino, so it is connected to the receive pin of Arduino. The pins 0 and 1 are TX and RX pins respectively in the Arduino Uno. Then I have controlled enable A and enable B pins to pin number 5 and 10 of the Arduino. As you might have noticed that for controlling the speed, we need pulse width modulation output. And the pulse width modulation pins that are on the Arduino have a tilde sign, as you can see over here. So both the pins 5 and 10 have a tilde sign, means they can provide PWM output, and so I have connected them on these two pins respectively. You can change the pin numbers, but make sure that both enable A and enable B are on PWM output pins only. And in between, the input 1 to 4 are connected on pin numbers 6, 7, 8, and 9. The two output pins over here, output 1, 2 is connected to one motor, and 3, 4 is connected to the other motor. As I mentioned before, if according to the logic, your motor was supposed to move forward, but it's moving in the opposite direction, you can just simply interchange these two connections of the motor that's moving in the reverse direction. This way, your motor will get the correct signal at the correct time and it will move in the desired direction. So, this is the circuit diagram. Next is the working. So, as we know that we are going to make a web page on the Bolt cloud. So, whenever we click a button, that button from the web page will send a particular data to the Bolt server. That server will send that data to the Bolt cloud that is on your car. From the Bolt cloud, so as you can see here, send data as per the button pressed via Wi-Fi. So the Bolt cloud or the Bolt server sends the data to the Bolt module that is on your car. Then that received data to the Bolt module is sent to Arduino using the UART communication, using those two pins RX and TX that we had seen before. These signals come to the Arduino. According to these signals, say if you have pressed the forward button, the Arduino needs to turn on those two pins, IN1, IN2, IN3, and IN4. There are four pins. So Arduino needs to give signal to any of those two pins to turn the motors forward. So according to that logic that will be in your code, the Arduino sends signals to the motor driver, and the motor driver is something that actually powers the motors. Arduino just sends the signals to when to start the motors and what should be the speed of the motors. But the motor drivers are the main source of your motors that will provide them the power. So motor driver powers the motors accordingly and it drives the motors. The next is the hardware setup. This is the bottom view of my car actually. I have used a transparent acrylic sheet. The On the bottom side there are two motors that, as I said before, I have connected on the rear, and in the front is a caster wheel. If you want four motors, you can connect the other two motors, one over here and one on the opposite side. So first you'll have to solder your motor leads and attach them to the chassis, attach your caster wheel as well. Then on the top side, there'll be a bolt module. As you can see here, this is the bolt module. This is my Arduino. This over here below the bolt module is the battery that I have used to power up my Arduino. A jack from the battery goes to the Arduino, and my Arduino output pins on the 5 volt are connected to the Bolt module. So my Bolt module is powered using the battery of the Arduino. This is my motor driver. The motor driver has these 6 wires, as you can see over here. These are the output wires that we saw in the circuit diagram. These are the enable pins and the input pins. Over here, my motor is connected to the motor driver. These are the output pins of the motor which are connected to the motor driver. Now I have used four batteries over here. Actually, if you have a high power battery, you don't need four. But because I have used 150 RPM motors and they were drawing a lot of current, so the voltage of a battery dropped suddenly. So what I did was I used two 9-volt batteries in series. The other two were also in series. So in total they were 18 volts, and then I made them in parallel to increase the current that I provided to my motors. So that's how I used four batteries, but in total the voltage is still 18 volts, and I have used a separate battery, fifth one, for my Arduino. So there are total five batteries, but if you can get a better quality battery that is of probably a higher volts and probably of higher power rating, then you may avoid using these many batteries, as the motor driver itself can sustain up to 35 volts. So you can get a high power battery or a power bank as well and then connect it to the car. So this is my hardware setup. Next, we shall see the codes. First, I'll show you the code of Bolt Cloud. Yeah, so this is my Cloud. That this is my code that goes on the Bolt app or the Bolt Cloud. I'll show it to you on the board as well. See, when you make a new project and you go to the code section, I have added this code that I'll be explaining you soon in this, and then I've uploaded it to my board. The first thing is the HTML tag. HTML tag is the main tag that consists of all the other tags in the web page. This is my head tag. Head is the title that I've given is control the car. Now this is not visible on the web page, but as you can see here, it's visible over here. So this is the text that you put in the head tag. This is my web page that I've designed. Going back to the code, the next is the body tag. The center tag is used to center align the uh, whatever the next few sentences that you'll be writing inside that tag. Then H2 is a heading tag. There are total 6 heading tags of varying sizes from H1 to H6, and H1 being the largest and H6 being the smallest. I have used H2 over here because it gives a medium sort of font size. This is the font size of the H2 tag. Next, I have given a few break tags. Break tag is used to, get a spacing of a line. So here you can see there is a gap in the page before my next button comes. So this is done with the help of break tag. Again, I've used a center tag. Then I've used a button over here, which has the name forward. This over here is the name, and this on click is an attribute, which means that when I click that button forward, it moves to a forward function that I have written few in the code itself. Right, we'll see that function later, but this is what happens when I click the button forward. So on click means whenever I click the button forward, it should move to this code over here. Similarly, I have used NBSP tags as well. NBSP stands for non-breaking space, which means that I wanted to give a break between a space between this button tag and the first letter F, and also here after the D and the button tag. So here I've used NBSP. Then I have used break tags again and defined similarly three more buttons. One is left, stop, and right. The on click function is same over here. When I click ref on the left button, it moves to this left function. Here a new thing is that is style. Style means the font color that is of the button of stop that I've changed to red. So as you can see over here, the stop is visible in red color. That you can that is of the button of stop. So that you can do via the stop sign. The color tag. Okay. Then similarly, I've defined a backward button. Now moving to functions, first thing is that I've done is I've made an XML HTTP request. Now what is an XML HTTP request? It is an object that interacts with the server which enables the transmission of data from the web page to the server without refreshing the whole page. That means when I'm clicking this button forward, you can see that it's getting clicked, right? So without the page getting refreshed, what it's doing is it's sending some data from this forward to the Bolt server. So this is the function of XML HTTP request tab. So I have defined a variable which is HTTP, and I have called this function over here, and I have stored its value in the HTTP. Now the function forward is supposed to be run whenever I click this forward button. In the forward button, I have used two commands, that one is http.open and one is http.send. This http is same as this variable that we have defined over here. You can name it anything else except for http, whatever you want. This http open has a type, in the after the bracket, the first thing that is supposed to be inside this is the method. The method can be get, post, or anything like that. The next is the URL of your server. That means wherever you want to send that data. So as you can see over here, this is the my cloud Bolt's cloud's address. Here your API key is the API key of your Bolt device, and your device ID is also the device ID of your Bolt device, because you have to send that data to one particular device, right? So you need to mention that over here. You can uh, either remove this and write your number, or what I've done is I have taken these two values from the Bolt cloud as well. So I have directly sent the data to that particular URL and send the data on that. Now, this forward that you can see here, this is the data that is being transmitted. As you can see, data is equal to forward. So when I press the button forward, this capital FORWARD is the data that is actually going to the Bolt module, and from the Bolt module it is going to the Arduino. Right now, the use of this data that we'll see in the code that we have written in the Arduino. This false is for asynchronous transmission. XML HTTP request transmits in two ways. One is asynchronous and the other one is synchronous. So this is for asynchronous. Asynchronous I've given false. So it will be transmitting in a synchronous manner. This HTTP send is used for sending the request to the server. Similarly, this function was for forward. Similarly, I have mentioned other functions as well. This backward sends the data backward to the server, and from the server to the Bolt. The function write, which executes when we click on the right button, sends the data capital right. Then left sends the data left, and stop sends the data stop. I'm sorry. Also, the script tag over here is used to write the JavaScript functions. All these are HTML functions and all these are JavaScript functions. Then I have closed the body tag, and finally I've closed the HTML tag. I hope you're clear with all this. If you have any questions, I'll answer your questions at the end of the session. So please make sure you note it down somewhere if you have any. So yeah, this was the code of the Bolt. Now we shall go to the code of Arduino. This is my Arduino code. The first line here, what you can see is Bolt Arduino helper.h. This is a standard library which interfaces Bolt with Arduino and includes several functions such as to handle command, and it also supports UART. So a few functions that we'll be seeing later in the code, like this over here, Bolt IoT.handle command and Bolt IoT.set command string. All these are previously already mentioned in the Bolt IoT in this library file, and so you can directly just call them if you have included that library over here. Else you have if you didn't have this, you'll have to write the entire code for getting the data and transmitting it to the Arduino, but that is done with the help of this library, so you can just directly include the library. The next is the defining all the pins that we have used. So as you can see over here, the left motor 1, 2, right motor 1, 2. These are the pins IN1, IN2, IN3 and IN4 respectively that you might have noticed in the circuit diagram. We had used pins 6, 7, 8 and 9. Now, PWM motor L and PWM motor R are for enable A and enable B pins. So before you start coding in the Arduino, you'll have to define which pins you have used in your program or in your hardware connections. And these names that are left motor 1, motor 2, etc., you can name them anything as you want, but because of clarity, I have named them in such a manner. Now this is the PWM value that I have set for my motors. The PWM value you can set is between 0 to 255, any value, and I have set 100 because that is mm, you know normal speed for motors that you saw in the video. So these PWM values will go to these enable A and enable B pins. Then this string command function is for the data that will be coming from the Bolt IoT to the Arduino. Now, as you can see over here in the setup function, I shall show it to you in the later part, but there is a line which is serial.begin 9600. As I mentioned previously, a UART communication can be of varying speed. So this 9600 is a fixed baud rate at which the UART will keep on sending the data to your Arduino. So that is a fixed speed. Baud rate means bits per second. So that data, that is the transmission speed of your data from board to the Arduino. All right. Next, we have used certain functions in the code that are defined over here. Now we'll talk about the setup part of the code. In the setup part, I have set up I have defined the output pins. So all the pins left motor 1, 2, 3, right motor 1, 2, and PWM L and R that were IN 1 to 4 and enable A and enable B. These are the output pins. That means we need to configure them as output pins because we are sending a data from Arduino to that. If we were supposed to take any data as input, we were supposed to write it as input, but because we are sending the data, we have mentioned them as output. Now this Bolt IoT begin.serial is the starting of the transmission. This means that whenever the microprocessor will find this command, it will start the communication from Bolt to the Arduino using UART communication, and this is the baud rate at which it will communicate. There are two functions over here. First one is BOLTDIOT.set command string, and second one is BOLTDIOT.handle command. Now, for those of you who haven't used Arduino before, this is the code that is supposed to go in the Arduino IDE, and it has two parts. First one is setup. This portion of the code is run only once when you just upload your code to the Arduino, and this function is loop. The loop function is something that will be continuously run on a periodic interval. So this BOLTDIOT.handle command is a function to continuously check whether if there is some data via the UART transmission or not. So if, say for example, you have pressed this forward button over here, then a message that is capital forward that we have seen over here in the bolt code, this is the bolt code. So here the capital forward, this is the data that was supposed to be sent to the Arduino. So this BOLTDIOT.handle command will continuously check, and it iterates through the whole list of commands and calls the command function depending on the command received. So if it receives the command capital forward, it will check the list of the commands that it has, and it will do a particular action. So here you can see over here BOLTDIOT.set command string. If it receives this capital forward command, it moves to this forward. Now this set command string tells the library that which command to look for and which function to call as a response. That means that if it receives this command, it moves to this forward uh, process. This forward process is as defined here in this code, which I'll show you in a while. So if the data that is received is this forward, then it will move to this forward loop. If it's backward, then it will move to the backward loop. If it's left, it will move to left, and so on. Now we'll see what are these functions. So here I have defined a function. The type of the function is string because it receives a string in the data. This command is forward. So whenever it receives forward, it moves to this loop. What happens in this loop is that it has to move forward, right? So IN1 pin and IN2 pin control the left motors, and these two pin control the right motors. So I have made one of the pins low and the other one high. So it will turn the motor in one direction. And the value that has supposed that we mentioned for the speed, this was value PWML. So that at that speed these motors will run. So digital write means low and or high, and if you want to talk about speed, you have to use a function called analog write. On that PWM motor L and PWM motor R, you have to use analog write because we are controlling the speed using the PWM pulse widths. Okay, so that's analog function. Then I have given a fixed delay. The delay time is mentioned over here, 25000 or 2500. This is in milliseconds, so it will give a delay of 2.5 seconds in total. So actually, what you can do is you can change this delay time, and you can set that how much your car should move when once the button is pressed. Here I have set it to 2.5 seconds. So if I press the forward button once, it will move till 2.5 seconds. And then I have made all of them low. So because all of them are at the same polarity, the motor stops working. Instead of low, I could have also written here high for all of them. Again, because they were at the same polarity, that is IN1 and IN2 were at the same polarity, the motors would have stopped working. At the end, the when the function ends its execution, it returns a statement which is success forward. So and it stores it in the this variable. This is a pointer that points to a location that is stored in the data variable. So the this message success forward will be stored at that particular location. Similarly, if the pressed button was backward button, then it would have moved to this loop. Here you can see that I have changed the polarities of the motor. First it was low high, here it's high low. So the motors now are now moving in the opposite direction. And again, the analog write will specify the value of the PWM pulse or the speed at which the motor moves. This is similarly the delay time, and then there is low. The next function is the right. Now if you want your car to move right, what you have to do is stop the right wheel and just move the left wheel. So you can try it yourself. If you have a phone or a book in your hand, just don't move the right part of the book, and just try to force the left part of the book and in the forward direction, and you'll see that the book turns towards your right. Similarly, if you want to move it left, just don't move your the left side of the book and force it from the right hand side, so it will turn left. So that's the logic that I've used over here. Or what you can do is you can turn your book. If you want to move right, turn your book from the right hand side backwards and from the left hand side forward. Then also it will move, but right now it will move at a higher speed because you both the wheels are working and they're moving in the opposite directions. So actually, that is what I have done over here. My one wheel moves forward and one wheel moves backward. As you can see, it's right turn. So my right wheel is moving in the backward direction and left wheel is moving in the forward direction. This is the speed. And similarly, in left part, the wheel is moving in backward direction and the right wheel is moving in forward direction to turn left. Also here also have given the same delay amount. That's why you might have seen that in the video the car rotates like for a few seconds. So that's because of this. You can reduce this delay time and you will see that the car only moves for a lesser amount of time, and hence it will turn only a little bit. So that all modifications you can do in your code as well. You can give it a very little time, and so the number of times you press your button, that only that much angle you'll be able to control properly with the car. This is the stop command. Whenever you press the stop button, all the motors should stop. So it will go to low. And this is again the setup phase that I've already explained before. And this is the loop phase. So this is the loop part will be continuously working. So whenever any data comes on the Arduino, it will check if what the data is, and accordingly it will send you in that particular loop. So this is the code that is supposed to be uploaded in your Arduino. And this is a look of your web page that you'll be able to see. Also, you can see this web page or this particular thing in your phone as well if you open it through your Bolt IoT application, and you can control your car using your phone as well. Now we're coming towards the end. So this is the scope for future development. This robot that I just made, uh, it just moves forward, backward, right, or left according to the buttons that you pressed. Now, if you want your drone to detect that if there is an obstacle in between, it should stop or it should turn to a particular angle or it should move in reverse, then you can add a sensor such as ultrasonic sensor or some other distance or proximity sensor to make an obstacle avoiding robot. So the only changes in your code will be that you will have to uh, in the hardware you'll have to attach the sensor, and the sensor might have been working via any communication like UART or I2C, or you can give the output of the sensor to the any GPIO pins of the Arduino. And in the code you'll have to make any changes. That entire code will be in an if condition, that if the sensor detects anything, then take reverse or something. That could be a logic that you will use. Second thing is installing a camera to see view of all the places your car can reach, and you can just record and make a car that records the stuff and you can take it to places. The third thing is modifying the code to make a voice control a gesture controlled robot by adding a voice gesture features instead of the buttons in your web page. Like you can see, you can add that specific data that whenever you say some word like forward, then it will move the car in the front direction, and if you say backward, then it will move in the backward direction or something. There are also ready made apps for that, so you can just install a, uh, that app inside your phone and connect it via Bolt. Also, you can add a servo motor controlled arm to make a pick and place robot, which is controlled by the remote made on Bolt Cloud. So you can make a remote, like a joystick type remote, using the HTML tags and all, and you can add a servo motor that will properly control the arms, that will properly control your arm, which can grab a particular object and move to another place and drop it over there. So that also you can do. And there are several other sensors available in the market that you can try. If you have any better suggestions, you can leave it in the comments as well. These are some of the references that I've used. And at the end, great is the art of beginning, but greater is the art of ending. So with this, we come to an end of this presentation. And thank you. Thank you for being a great audience, and thank you for your kind words in the comments. Um, Before we move to the question answer session, I'll like you all to see a video of the Bolt.
This is John. John is 200 years old, confused, and lost. 100 years ago, he started building an IoT product, but as you can see, he's still working on it. How are you doing, John? There are many makers, developers, and hobbyists who waste a lot of time, money, and energy building an IoT product. Going the traditional way to build such a product is boring, cumbersome, and most of all, tough. So what should people like John do? They should get this. This is Bolt, an IoT platform that lets you control or monitor things over the internet. With Bolt, it's just a few steps. Connect your sensors or actuators to Bolt, write a short code, visualize the data, or control your devices over the internet. My bike tells me it's using too much fuel and I better get it serviced. My plants tell me they're not getting enough water or sunlight. So what Bolt basically does is that it collects and visualizes the necessary data for monitoring from any of your sensors. You can also remotely operate anything, like a robot, and run machine learning algorithms to predict its battery health over time and replace it before a breakdown. Suppose you want to know how efficiently you run every day or keep a track of it on a daily basis. You can do this either by taking notes or by developing a simple monitoring or control system using Bolt. Bolt is a completely integrated platform. The Bolt app identifies your chip when it's powered on and connects it to the internet network you've set up. It then establishes a secure connection with your cloud account and notifies you once it's complete. The cloud dashboard lets you create products in just 2 steps. All you need to do is configure your hardware and write a code to either monitor the data from your sensors or control a device. The platform's open APIs let you add your own tools to the dashboard and connect it with different apps for your own unique project. The cloud lets you receive notifications of critical events and with a single click lets you run machine learning algorithms to predict future data or to even detect anomalies in your machines and prevent a failure well ahead of time. The platform is language independent and lets you work with any of your favorite coding languages. This helps you save time and avoid unnecessary complications. And the best part is the most economical IT platform available. Bolt is applicable in large scale industries as well. You can integrate Bolt with your heavy duty machines like this, this, oh sorry, and this, and ensure they're performing at their optimum level. Put simply, Bolt is where all your worries to build an IT product or project come to an end.
So as you see, the possibilities are limitless. Whether you want to monitor your own performance or the performance of your products, whether you're a businessman, a developer, or a maker, whether you're from the banking industry, FMCG industry, or the automobile industry, Bolt will save you a lot of time and effort. And we want you to be part of this revolution with Bolt.
Yeah, so now I shall answer the questions. So how the motor receives the data that it has. Um, See, first, I hope you're clear that how the Arduino will get its data from the Bolt cloud. Right now, I'll show it to you in the code. So whenever the Arduino detects that it got a signal, say forward, it moves to this loop that is forward. Okay, and it makes a certain pins high and a certain pins low. Then whenever say iron 1 is high, iron 1 is high and iron 2 is low. In terms of Arduino, high and low means 1 and 0 simply, because when you write digital write high, it will send a data 1, and if you write low, it will send a data 0. So according to this truth table, you have set a particular PWM for the speed at the enable A pin. Then you have made IN1 high and IN2 low. So this is already 1. This is actually not 1. It has some speed value, but it's there. It's on. And IN1 is 1 and IN2 is 0. So the motor is on and it's turning in the forward direction. So according to the logic in Arduino, there will be some output on these pins from the Arduino, and there'll be some values on these pins. According to these pins, there is a logic, not a logic, but there is a path of voltage in this motor driver. So if this is high and this is low, one of these terminals will be high and the other one would be low. One of these will be positive and the other one would be negative. So the motor will move in one direction. If you make this opposite, the output of the terminal will be different. So the other port will be high and the first one will be low, and so the motor would run in the opposite direction. So that's how the motor driver controls the operation of your motors. Mm, the next doubt is, can we use servo motor to control the direction of your car? Yeah, I think you can use servo motor, but the thing with servo motor is that you continuously have to, run it in a loop, and you continuously have to give a certain values high. So there is a fixed logic of servo motor. So it's better if you use it for controlling the direction and all, because servo motor is very precise. If you want the movement at say 10 degrees of angle, then servo motor can give you that. But in continuous operation, these BO motors are better than servo motors, or you can also use gear motors instead of these. So for arms or something, you can use a servo motor. Anything else? Yeah, sure. Once I successfully make my drone, I'll try to make a video on that too. Yeah, sure. I'll be sharing the PPT. I'll put it in the description box or somewhere, and you'll get it in some time. Also, if you have any doubts further, you can drop it in the comments below, and even after a few days or something, if I check it, I try to answer it. Yeah, you can use a microcontroller that is compatible with Python, and you can use Python as well. You just have to find the right microcontroller. That's it. Okay, so I hope there are no more questions now. So thank you all for joining, and uh, um, Rupert, can you be more specific? I couldn't get your question actually. How it changes direction. So the direction changes based on the output on these ports. So see, if I give high on IN1 and low on IN2, both these ports are for the same motor. But if I reverse that, if I give high on IN2 and low on IN1, it will move in the opposite direction. So that's how your motors move backward. Now for right and left, you'll have to move one motor in the forward direction and one motor in the backward direction, or you can just simply stop one motor and move the opposite motor. As in, if you want to turn right, you stop the right motor and just move the left motor in forward direction, so it will turn right. And similarly for the left case. All right. So if you have any more doubts, you can drop it in the comments below. I'll answer in the comments. And thank you so much for this wonderful session. You all of you have been a great audience, and thank you so much. So we'll wind up with the session. Thank you. Bye bye. Have a great day.
So, if any one of you is also looking at having a very detailed training, we have an Internet of Things and learning training for you. We've had more than 50,000 students across India who have joined this training till date, and it's very popular training. And we teach you all the concepts right from the basics. We teach you concepts like HTML, Python, and even JavaScript, everything that is required to build your own Internet of Things and machine learning projects. We're going to be teaching it in a very step-by-step manner. So if you're somebody who's looking at building your own IoT projects, this is something which is I would highly recommend. In fact, Nunali, who was the speaker today, but she was one of the students who took up the training and learned as part of this training. So if you're looking at learning things in detail, I would highly recommend you can join the training, and we have a very special offer. If you can just check the details below, you can register for the training. Regularly, we charge 9,600 for the training, but you can just pay for the hardware kit, which is 2,750, and you can join this training, and we'll offer you the training for free. Also, you don't have to pay right now. You can just register, and once you get the kit at your home, you only have to pay at that time. And also, this training we also help students get internships as well. So even once you complete the training, if internships is a requirement for you, then we are there to help you with that as well. And this training has a lifetime access. So you can start now and take the training anytime. So if you have exams or you can take it up during your holidays. A lot of students even take it during the summer break, so it's also something ideal that you can look forward to. And if you have any questions as well about the training, you can visit our website as well, shop.boltid.com, and you can see a WhatsApp chat button, so you can chat with us. Let us know, and we really look forward to also having you as part of this extensive training that we are offering. And thank you so much all for attending this session. I hope you had a great learning session, and we're looking forward to teaching you more such concepts and helping you become really good engineers and learn the concepts of IoT and machine learning and build your own projects. Thank you so much. Thanks a lot. And do check the link below, and you can register now. As I mentioned, you can pay for the kit only when you receive the kit at your home. Right now, if you want to register, book within the offer, just you have to fill in the details, and we've just got, I think, maybe 1 or 2 seats left. So if you are looking at it, click on the link below and make sure you register. Thank you.